So, welcome to one more topic in object oriented programming, that is polymorphism. This polymorphism is one of the object oriented programming principle next to encapsulation, abstraction, and inheritance. Polymorphism is the fourth one, message passing is the fifth one. So, coming to the polymorphism, poly means many, morph means shape, morph means shape, many shapes. So how this many shape, this word, this term fits in object-oriented programming is many, and instead of saying many shapes, many ways of implementing method. And if one method implemented in many ways, the same abstraction example, admin salary calculation, HR, various other, employee salary calculations. And salary calculation, that method implementation is not constant. That is changing from one type of employee to another type of employee. And to calculate salary is having many not shapes, many implementations. Right? That is what called as polymorphism. When a method is having many implementations, when a method is written many times with different implementations, that is called as polymorphism. So polymorphism mainly deals with two things. One is method overloading, and second one is method overriding. We will discuss this method overloading and method overriding in one simple point. Method overloading takes place only within the class. Only within the class. Method overriding takes place between superclass and subclass. Method overloading takes place only within the class. Method overriding takes place between superclass and subclass. Therefore, method overriding, superclass and subclass, two classes are required. For method overloading, one single class is sufficient. We'll come up with an example. One method with different signatures is called as method overload. One method with different signatures is called as method overload. Takes place at the same time. Here we used one special term called signature. What does the signature mean? Method signature mean is whenever we are writing method, we'll write access specifier first, access modifier next, return type next, method name, followed by parameter type, parameter name, and a int a comma int b comma int c, like that we'll write data type, and then we shouldn't call it as data type, we should call it as parameter type, then followed by parameter name, parameter 2, name 2, parameter type 3, parameter name 3, and so on. Method signature means the number of arguments, type of arguments, order of arguments. Method signature tells the number of arguments, type of arguments, and order of arguments. For example, suppose if method is having one int a comma double d comma string str, how do you tell that this method signature has? This method has 3 arguments. The types are int double string respectively. Their order is also a int double string respectively. Because the method signature will tell how many number of arguments and what are the types of arguments, and in which order the arguments exist in the method, and the declaration is what called as method signature. And with this method signature, we can identify, even though if two methods are written, the two methods can be differentiated. If two methods are written with the same name, still they can be differentiated by seeing their signatures. And then through signatures, we can distinguish whether method belongs to which method. That takes place within the class. That takes place within the class. One method with different signatures. One method with one signature having many implementations. One method with one signature. And there is one method. That method name, signature, return type, everything is same. But the method is having different implementations. How a method can have many implementations within a class? How one method can be written many times with the different implementations with the same method name and signature? Changing signature is called method overloading. The same signature, how the same method can be written many times? If you try to do that, immediately we will get a compilation error saying that method is already written once, you are writing second time, third time, fourth time, and so on. Compiler will give an error. Method is already an existing method. You cannot duplicate class names, you cannot duplicate method names, you cannot duplicate variable names within the same scope. So how come a method with the same signature can be implemented many times? Same method implementing, and a method with the same name, with the same signature can be implemented many times in many subclasses. Method implementing in multiple subclasses. Method overriding takes place between one superclass and many subclasses. But when a method is declared or implemented in one superclass and implemented or rewritten in subclasses, then it is called as overriding. Coming to method overloading. Method overloading and method overriding comes under polymorphism, also called as static and dynamic polymorphism. Why it is called a static and dynamic polymorphism, that we'll discuss. Method overloading is a static polymorphism. Method overriding is a dynamic polymorphism. That's why method overriding is also called as runtime polymorphism, dynamic polymorphism, runtime polymorphism. Same method calculates are implemented in different subclasses. Through a factory method, we'll choose any one of the subclass object, and on that we'll invoke the method. So, is method overriding is nothing but a runtime polymorphism. That's what it is called as dynamic polymorphism. Method overloading is static polymorphism. That means method with the different signatures exist. Whichever method you want to call, you call method with the same signature. And if you call method with int, double, and string passed as arguments, only method written with int, double, and string as a parameters. Exactly the same method will invoke. So at runtime, dynamically choosing the method doesn't take place. According to the arguments passed into the method, the matching signature method will execute. So there is no dynamic as such in method overloading. While calling the method in method overloading. So then coming to method overloading, writing same method many times with different method signature is called as overloading. Overloading considers number of parameters, type of parameters, and order parameters. Overloading takes place within the class. Which statement do you write very often in Java programming is system.node.print. Print or println, isn't it? Do you know the signature of println method? What type of argument println method takes? In this println method, we can pass byte variable as argument, short variable as argument, float variable as argument, int variable as argument, long variable as argument, float variable as argument, double variable as argument, character variable as argument, boolean variable as argument, array as an argument, any string object as an argument, any class type object as argument. Any class type object can be passed as argument. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 any class type object means string is also including a class type object. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a system.out.println method is designed in such a way that we can pass any 10 types, any of the 10 types, primitive or secondary types, as arguments into the println method. It will accept and print that value, prints that value. How is it possible that single println method can take any of these types? Because whenever I write a method with string as a parameter, I should pass only string as argument. If I pass int and float as a parameters in the method, I should pass only int and float as arguments. Isn't it? But how print method is written in such a way that it can take boolean as argument or short as byte as argument or short as argument or long, int, long, float, double. How come? Because in this print sim class, this out is nothing but an object of print sim class. This class exists in Java type of package. In the print sim class, this println method exists that is overloaded for 10 times. Println method overloaded for 10 times. You type java.lang.string, you will get the println method for 10 times. Print method 10 times, println method for 10 times. Roughly 10 to 11, 12 times each method is implemented. Print and println methods. There is a best example of method overloading in Java. And a method one, I'll give you so many our own user defined examples also. Here is one of the examples. Here is one example. The example is previously, I'm writing one class called overloading demo. Previously, there is one method called calculate tax in the e-commerce applications and in trading and financial applications, trading applications and e-commerce applications. Customers will come and e-commerce applications. Customers will come and buy the products, buys various types of products, mobiles, tabs, various things. Through online, you can purchase anything, right? Even if you go to grocery store, also you can buy many things. Generally, household items will purchase through a grocery store. All rice, sugar, etc., etc. Perfumes, even body deodorants, car perfumes, even socks, masks nowadays, masks and sanitizers. All whenever we go to store, we'll buy as much money as we are having. We'll almost buy the entire shop. So, while placing all the items in the cart, different here perfumes are there. We'll use cosmetic items. We'll use electronic items. We'll use household regular items like rice, sugar, etc. Household items, and sometimes we'll purchase oils, etc. Sometimes we'll purchase soaps, brushes, toothpaste, different household commodities. So whenever you purchase different products and different items, item is nothing but as many number of quantities of each product you purchase is nothing but one item. Suppose if you buy 5 synthol soaps, that is one item. Synthol soap is one product. 5 synthol soaps you are purchasing, that is one item. Item is nothing but as many number of quantities of a product you're buying is nothing but one item. So we'll buy different commodities of items. So based on each commodity, government will fix some tax to some household commodities. The tax is 8.5%, and for sugar, rice, etc. Because for our livelihood we consume that. For that the tax is less. And for the perfumes, etc., the tax is 15%. For the electronic items, the tax may be 18%. On some export goods, the tax may be some 25%. Okay? The taxes may range from 8.5 to 10, 20, 15, 20, 25% also sometimes. The taxes vary. So, in the calculate tax method, if you pass any product amount, internally the tax, and previously the tax is constant. To any product you purchase, the tax is constant. That amount, that product amount into 12.5 divided by 12.5% tax. The tax amount will come. If you pass amount, 12.5% tax will be calculated and that amount will be returned through a client. And if you call calculate tax method and pass 1000 rupees as argument of 1000 rupees, 12.5% tax will be calculated. 10% means 100 rupees, 12.5% means 125 rupees tax will be calculated that day. You will be asking, can't you do it manually? Can't you calculate manually? The system intention is not to manually calculate. Okay, that is why we write programming. We write programs, right? So previously, to all the commodities, the tax is 12.5% is common, constant. Now the same products, government has decided for some eastern states like above the Bihar and Orissa, Bengal, Tripura, Manipur, Assam, Mizoram, to eastern states. We want to, we want to give some less tax of 10.5%. For UP, 11.5%. In AP, 12.5%. In the rest of the states, some 13.5%. Something like that. The government has decided that the tax calculation also want to vary from state to state or region to region. North region, east region, south region, west region. Region wise or state wise, the tax calculation want to change. That is what government has imposed one rule. So immediately, instead of modifying the calculate tax method, existing calculate tax method, we'll write calculate tax method one more time with the double amount as a parameter, with string state as an additional parameter. String state as an additional parameter. In this method, based on the state, we'll check if the state is AP, you calculate 12.5% and return to client taxes. If it is UP, 11.5%. If it is other than that, calculate and return 10.5% tax. So instead of modifying the existing method by taking one more additional parameter, are you changing the tax calculation or not? For irrespective of the state, you call this method from state to state. If the tax want to vary, you call this method. Instead of disturbing the existing method, you write one more method with the additional parameters and implement logic in a different way. This is called as method overloading. Same method written twice with a different signature. Here signature is double amount, single parameter. Here this method is having two parameters, double amount, string state. This is one example. And there is one more example. Writing different method names for different method signature. If method overloading doesn't exist. If method overloading doesn't exist, what happens? If method overloading doesn't, say calculate tax example is clear. If method overloading, if our object oriented programming doesn't support method overloading, let us assume, what happens? If object oriented programming doesn't support method overloading, then what happens if you ask me? Then it will be quite similar to the procedural programming. So if object oriented programming doesn't support method overloading, and the same method we can write many times, only by changing the method signature, we can write same method for many times. We can repeat same method for many times. Suppose if programming doesn't support method overloading. For example, I want to write one add method to add two integers. I want to write one add method to add three integers. I want to write one add method to add 4 integers, 5 integers, so on, up to add method which want to accept and add 10 or 20 or 30 or 50 integers. So if method overloading doesn't exist, and a method name you need to write uniquely throughout the class. Suppose if you want to write add method to take to add two integer values, you write one method name called add to int. In this you pass two integer parameters. Suppose if you want to add three integers, add 3 int. The functionality is same, addition. But to add 2 integers, 3 integers, 4 integers, 5 integers, if you keep on changing the method names, how difficult it is to every time write a new function name to the developer and as well as to the user, how difficult it is to remember these functions. Because the developer sometimes may write function add numeric to int, and sometimes developer may write add 3 int, three. He'll write in words add 3 int. How user can predict how the method name is? To add add underscore 4 underscore int 4 underscore int add underscore 5 underscore int. How client remembers that which method name is given for adding 2 integers, 3 integers, 4 integers, 5 integers. And every time finding some unique method name, and every time choosing one unique method name for each method is also difficult for a developer. Instead of writing different method names for different signatures, if you write add method with int two integers, add method with 3 integers, add method with 4 integers, add method with 5 integers. So same add method repeated for 2 parameters, 3 parameters, 4 parameters, and 5 parameters, and so on. Method name is only one, but it can take different. Same as print example, which can take 2 int, 3 int, 4 int, 5 int, 6 int, 7 int, 8 int, n number of integers as arguments. So method name remains same, only signature changes, and internally based on the signature, based on the number of arguments, the addition operation will take place. So to the developer and as well as to the user also, it is convenient to write the methods and to remember the method names. If method overloading exists. But similarly, add method with 2 float, 3 float, 4 float, 5 float, etc. Okay. But fine. Here, how many add methods are it? Even method overloading also sometimes overloads our mind. See, for 2 int you wrote add method with 2 int. For 3 int parameters. For 4 int parameters. For 5 parameters. I want add method to add 10 parameters, 20 parameters, 30, 50, 100, 16, 18, 17. Randomly I'll tell that I want to add from these many number of parameters. So how many add functions are you going to write? Keep on. Then doing too much overloading also leads to the complication of the program. Developer cannot write those many number of methods. It is hard to write those many number of methods, right? People will laugh if you write those many methods. So what you will do is the best answer is if you write add method with int array as a parameter. So instead of writing add method with 2, 3, 4, 5, how many add methods are you going to write like that? If you go for method overloading with a simple add method, if you write with int array as a parameter array, please tell me the size of the array. Array size can be anything. The array size may be 5, 10, 15, 20, 100, 1000, 10,000, 50,000. Array has no limit. Whenever you are declaring an array, you can declare array of any amount of size. If method takes array as a argument based on the size of the array, those many number of values will be passed. So we can avoid writing add method for these many number of times. And the method overloading burden can be reduced with arrays. Internally, what we are doing in sum is equal to 0. I dot length. Length is a property in array variable. I dot length. We are finding the length. Int a is equal to 0 because array index starts from 0 to, suppose if there are 10 elements, 0 to 9 is the index. So int a is equal to 0. A is less than length and 10. A plus plus. Now the loop will automatically iterate from 0 to 9. Each time from the integer array, we are retrieving each and every element 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 element. That element we are adding to sum. Finally, we are getting sum. Array is one best alternative for writing add method so many number of times of the same data type. And there is one more alternative for the array, that is, this is called as varargs, variable arguments. So you write add method with int followed by 3 dots, and the parameter with 3 dots, and then followed by you write parameter name. You write any method with parameter type followed by 3 dots, followed by any parameter name. This is called as varargs, variable arguments. And this int triple dot is called as a varargs, so that into this method you can pass any number of integer values as arguments. And instead of array, for array one best alternative is varargs. But internally, how to find out the length of this? If it is array, we can find out the length of an array. If it is vararg, how to find out the length of an array? We cannot find out the length of an array. Such vararg should be used in for each loops. For int a colon I, and this is called as for each loop or enhanced for loop. In this for loop, right side we need to write array variable name, and the left side we need to write single variable name. Int a colon I. So I is array variable. From I, each index value will automatically populate into A. A length will automatically be found, and from the indexes, each value will be retrieved automatically. So just if you write for int a colon I, so as much as the size of I is, each element will come to A will be added to sum, finally sum will be written. So this is how, by using varargs, we can avoid even using arrays also as a parameters in the method. And now, here is one condition. While using vararg as a parameter in the method, two conditions are: a method can take only one vararg as a parameter. Point number one. A method can take only one vararg parameter. But whereas a method can take any number of int parameters, string parameter, float parameter, double parameter, char parameter, boolean parameter, we can take any number of parameters. But a method can take only one vararg as a parameter. That vararg can be used only as a last parameter of the method. And after vararg parameter, we should not write any other parameters. Vararg should be the last parameter of the method, and a method can have only one vararg parameter. If you satisfy that condition, you can go for vararg parameters. But don't write vararg as a parameter. Vararg is a parameter, and then other parameters. This will lead to error. And writing too many number of vararg parameters is also wrong. This is also wrong. So public int add int array. For array, you can put square bracket after parameter type or after parameter name. Here after parameter type, here after parameter name. Here int triple dot I is valid. Int I triple dot is wrong. We cannot put 3 dots to the vararg parameter. We should put 3 dots to vararg type. To type, we should put 3 dots, but not to the parameter name. So this is correct syntax. Add methods with string str comma int triple dot I. That is correct. Int I triple dot string is a wrong syntax, because after vararg parameter, no other parameter should exist. But advantage with array is, if you use vararg as a parameter, that should be the last parameter and only one parameter can be used. But whereas in case of array, a method can take any number of arrays as parameters. An array parameter can be at the beginning or at the middle or at the end. Array parameters can be any number of parameters in the method. Array parameter can be used anywhere in the method signature. And these two are possible only with array types as parameters. But vararg cannot be used like that. Vararg has its own limitations. String str comma int array is parameter valid. Int array comma string str is valid. Int two integer arrays, int I square bracket, int j square bracket in the str. Even 3 parameters, 2 parameters. You can write any number of parameters with arrays. But with varargs, this is the constraint. And coming to method overriding, we saw many examples on method overriding previously. In runtime polymorphism, in abstract classes, interfaces, in runtime polymorphism. In any previous videos, we saw method overriding example, that runtime polymorphism example. That can be treated as a method overriding example. So that method overriding is not covered here. Why multiple times? So the next topic is next to polymorphism, message passing is one more topic left. That we will discuss in the next video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.